Hello and welcome to my channel. Are you an electrical engineer, electrician, or student feeling stuck or confused by electrical protection devices? Don't worry, I'm here to clear up all the misconceptions. This video is special because I'll break down each aspect, simplifying their functions, differences, and the best applications, so you can truly understand and make the right choices. Whether it's your home, office, or industrial setup, choosing the right circuit breaker is crucial for safety and efficiency. Stay with us, and by the end, you'll have the knowledge to make the perfect choice for your electrical needs. Don't miss this ultimate guide to electrical protection. Let's get started. Before we move on to breaker selection and specifications, let's clear up two essential concepts: breaker protection rating and short circuit rating. I'm presenting the Schneider Electric 63A 4-pole MCB from the IC65N series as an example. The purpose is to make you understand the importance of electrical terms for choosing the right breaker. Okay, this 63A device plays a crucial role in protecting electrical circuits from overloads and short circuits, ensuring both safety and reliability. The 63A rating indicates it can handle up to 63 amps of current. If the current exceeds this limit for too long, the breaker trips to prevent overheating or damage. Being a 4-pole breaker, it's ideal for protecting three-phase systems, which are commonly used in industrial settings. Next, let's talk about two key features: UAMP and ICN. UAMP stands for Impulse Withstand Voltage, rated at 6 kilovolts. This means it can handle voltage spikes, like lightning surges, without damage. ICN, the rated breaking capacity, is 6 kiloamps. This rated breaking capacity is also known as short circuit rating. It ensures the breaker can safely interrupt fault currents up to 6,000 amps. If I summarize this, you can say this: the Schneider Electric 63A 4-pole MCB IC65N series is rated for 63 amps, has an impulse withstand voltage of 6 kilovolts, and a rated breaking capacity or short circuit rating, ICN, of 6 kiloamps. This is complete information. Only the 63A rating is not enough information. I hope you're clear now. One important point to clarify: the breaker's rating, such as the 63A capacity, and its short circuit rating, like the 6 kiloamp breaking capacity, are for the same breaker. Many new students or technicians might get confused and think these are different ratings for separate components. But no, they both describe the same breaker, just showing its capacity for handling normal current and the maximum short circuit current it can safely interrupt. Anyhow, it was an overview of breaker protection rating and short circuit rating before moving to breaker details for better understanding. I hope you like it. Don't forget to subscribe and like as a token of appreciation. Another most important thing to understand for technicians, engineers, and my students is the difference between earthing, grounding, and neutral. These terms are often confused, but they play very distinct roles in an electrical system. Earthing and grounding both refer to connecting parts of the electrical system to the earth, but earthing usually protects you from electric shocks. For example, the metal body of a motor is earthed to protect you from electric shocks if there's a fault in the wiring. If a fault occurs and a live wire touches the motor, earthing helps to safely direct that dangerous current away to the earth, keeping you safe. Let's take a closer look at how the motor body is earthed to protect you. You can see in the pictures how the metal body of the motor is connected to the earth. This earthing process is crucial because it provides a safe path for electricity to flow if there's a fault in the wiring. If, for any reason, a live wire inside the motor touches the metal body, the current would normally flow through the motor's outer casing and could cause a dangerous electric shock. But by earthing the motor body, the fault current is safely directed to the ground. This way, it prevents you from being electrocuted and protects you from harm. Here is another example of earthing the container body to prevent electric shock in case any wires unfortunately touch the container body. Okay, let's talk about grounding. Grounding is a bit different. It's about stabilizing the electrical system. For instance, the neutral wire of a transformer is grounded to keep the voltage stable. This is vital because during power surges, grounding helps prevent damage to the equipment. Think of grounding as a safety measure that maintains a balance in the system, protecting your electrical devices from high voltage spikes or other disturbances. Without grounding, voltage can fluctuate unpredictably, which might cause severe damage. Okay, the next is what is the neutral wire? In any electrical device, like a lamp, the neutral wire plays a key role in completing the circuit. The live wire carries electricity to the bulb, and the neutral wire carries it back to the power source. This flow of electricity wouldn't be possible without the neutral wire. It completes the loop and ensures the circuit functions properly. The live wire brings power to your device, and the neutral wire allows the power to return, creating a safe, continuous flow of electricity. In this table, I summarize the difference between earthing, neutral, and grounding. I hope with this difference, you may have better understanding in the industry and practical work. I hope you like it. In electrical systems, both MCCBs and MCBs are used to protect circuits, but they serve different purposes and are used together in certain applications. Let's break down how these two work together. An MCB is a small circuit breaker typically used for protecting smaller circuits with lower currents, usually up to 100 amps. It's commonly found in homes and offices to protect individual circuits from overload or short circuits. However, MCCBs are designed for higher currents, typically above 100 amps, and they offer better protection for larger industrial circuits. So how do they work together? In a large electrical distribution board, an MCCB might be used as the main circuit breaker for the entire panel or for protecting larger subcircuits. Meanwhile, MCBs are used to protect individual smaller circuits within the system. For example, an MCCB could be protecting a major feeder line, and individual MCBs would then protect specific devices or parts of the circuit downstream, like lighting, outlets, or motors. This combination of MCCB and MCB ensures comprehensive protection, covering both large and small circuits. The MCCB provides protection against high-level overloads and short circuits, while the MCB ensures that smaller, more delicate circuits are also protected from overload or faults. Together, they ensure safety, prevent electrical damage, and reduce the risk of fire or equipment failure. Let's quickly compare MCBs and MCCBs. MCBs, or miniature circuit breakers, are the household heroes. They handle up to 100 amps and are perfect for homes and small offices. Compact in size, they use a thermal-only tripping mechanism to protect against minor overloads, making them ideal for light-duty applications. On the other hand, MCCBs, or molded case circuit breakers, are the industrial powerhouses. They manage up to 2,500 amps, making them suitable for factories and large facilities. With both thermal and magnetic tripping mechanisms, they're built for high-power surges and demanding circuits. Unlike MCBs, MCCBs have adjustable settings for precise control and are larger in size, designed for industrial panels. In short, MCBs are for smaller circuits, while MCCBs handle heavy-duty systems, ensuring safety across all types of applications. Let's break down global MCB standards and types. MCBs are your first line of defense against electrical faults, and their type determines where they fit best. B-type MCBs trip at 3 to 5 times the rated current, making them ideal for low inrush loads like lighting in homes and light commercial settings. These follow IEC 60898 standards with a short circuit rating of 3 to 6 kA. Next, C-type MCBs handle 6 to 10 kiloamps and trip at 5 to 10 times the rated current, perfect for motors and general industrial use. D-type MCBs, the heavy hitters, manage 10 to 20 kilowatts, suitable for high inrush equipment like large motors and transformers. Meanwhile, Z-type MCBs with 2 to 3 kilowatt ratings are highly sensitive for delicate electronics. For industrial giants, UL 489 MCBs support up to 100 kiloamp short circuit capacity, while UL 107 MCBs protect specific appliances with up to 10 kiloamp ratings. The takeaway? Choose the right MCB to match your load and application for ultimate safety. An earth leakage circuit breaker, or ELCB, is a vital safety device that protects you from electric shocks and prevents electrical fires. It works by detecting ground or earth leakage currents and immediately disconnecting the power to stop potential hazards. Think of it as a life-saving shield for your electrical system, especially in homes and workplaces. The ELCB is ideal for protecting circuits in wet areas like bathrooms or kitchens, where electric shock risks are higher. Its ability to detect even small leakages makes it an essential part of any safe electrical installation. Always remember, having an ELCB installed is not just about meeting safety standards, it's about safeguarding lives and property. I am presenting Schneider Electric ILD32A 4-pole breaker with 30 milliamp sensitivity. This powerful ELCB is designed for ultimate safety. The 32A rating ensures it can handle circuits up to 32 amps, perfect for industrial and commercial use. The 30 milliamp sensitivity quickly detects ground faults, protecting against electric shocks and preventing fire hazards. Its 10 kiloamp breaking capacity ensures it can withstand high fault currents, and while the 4-pole design safeguards 3-phase systems. Always check these specs, current rating, sensitivity, and poles, to ensure you're choosing the right breaker for unmatched safety and performance. Ever wondered why some breakers are called RCCB while others are ELCB or RCBO? Choosing the wrong one isn't just costly, it can be dangerous. Today I'll explain how these devices work, and more importantly, how to choose the right one for your needs. Let's start with a quick question. Do you know the device protecting your home circuits right now? If not, don't worry, you're about to find out. Let's start with why understanding these differences matters. Imagine a sudden surge of electricity. It's like a flood rushing through your wires. The right breaker will block that surge and save your devices, but the wrong one, it might fail at the worst time. So, understanding these breakers is critical for safety and efficiency. First, we have the ELCB, Earth Leakage Circuit Breaker. It's an older type of safety device that trips when it detects ground leakage current through an earthing wire. Think of it as your home's shield against electric shocks. But here's the catch. ELCBs can only work if the earthing connection is perfect. Next, we have the RCCB, Residual Current Circuit Breaker. This is the modern upgrade to the ELCB. It detects leakage currents directly by monitoring live and neutral wires, meaning it's much more reliable, even if your earthing isn't flawless. For example, if there's a fault in your washing machine, the RCCB ensures the circuit trips before it harms anyone. Then comes the RCBO, Residual Current Breaker with Overload Protection. This is like the multi-tool of breakers. It combines the leakage protection of an RCCB with the overload and short circuit protection of an MCB. It's perfect for areas where both risks exist. For instance, in a workshop where you have multiple power tools, the RCBO will protect both the system and the operator. Finally, the RCD, Residual Current Device, is a category that includes RCCBs and RCBOs. It's the family name for all devices that monitor leakage currents and disconnect to prevent harm. So how do you choose? If you're protecting home circuits, an RCCB might be all you need. For more complex setups like an industrial site or a workshop, RCBOs are your best bet. And if you're looking at older systems, you might still come across ELCBs, but upgrading to modern RCCBs or RCBOs is the smarter choice. Remember, electrical safety isn't optional, it's essential. With these devices, you're not just protecting circuits, you're safeguarding lives. So the next time you're setting up or upgrading an electrical system, ask yourself, is this the best device for the job? With this knowledge, you can confidently make the safe and smart choice. I hope you got 100% understanding. And here's a quick glimpse at some industrial control panels. Each one is uniquely designed to manage and protect complex systems, ensuring smooth operations in industries. From panels housing MCBs and MCCBs to those featuring advanced VFDs and relays, every component has its role in keeping machinery safe and efficient. These panels represent the heart of industrial automation, where precision and reliability meet innovation. This is just the beginning. There's so much more to explore about how these systems work together. Stay tuned for deeper insights into their functionality and practical applications. If you're curious or have specific questions, drop them in the comments, and let's keep learning together. Thank you for watching my video. Don't forget to subscribe and hit the bell icon to stay updated with my latest tutorials.